Welcome everyone. Today I will discuss how to find derivative of a function with respect to another function. So if y equals to sine x, then if y equals to sine x, then dy by dx equals to cos x. So derivative of sine x is cos x. In this case, we assume that derivative is performed with respect to x. Unless otherwise stated, by derivative of function, we always mean derivative with respect to x. But if it is given, find derivative of function with respect to another function. For example, look, if I say find derivative of log x with respect to tan x, derivative of log x, dy by dx means derivative of y with respect to x. So it is at the denominator. So in case of two functions, we suppose first function as y. So what is dy dx? So dy dx is 1 by x. Now derivative is to be performed with respect to tan x. So let z equals to tan x. So dz by dx equals to sec square x. This is dz by dx. Now we have to find dy by dz. Look, dy means derivative of log y with respect to z. Z means tan x. So if it is given derivative of a function with respect to another, to call first function as y, second function as z, then perform dy by dz. Now by chain rule you know dy by dz, by chain rule dy by dz equals to dy by dx into dx by dz. So what is dy dx? 1 by x. And dz dx is sec square x. So this is 1 by sec square x. So 1 by x sec square x. 1 by x sec square x. So this is derivative of log x with respect to tan x. So you have to keep in mind that derivative with respect to another function, this will be at the denominator. So very simple. So main part is of derivative is derivative of function with respect to another function, derivative of inverse circular function, logarithmic differentiation. Next, number 2. So differentiate log sin x with respect to 2 to the power x square. So log sin x. So this to be noted, base is 2. So what is dy by dx? Dy by dx equals to 1 by sin x into log e base 2. Since base is not e, you have to multiply it by this. You know what is your basic principle? If z equals to log x base a, what is dz dx? So 1 by x into log e base 2. So since base is not e, log e base 2 into dx of sin x. Now 1 by sin x into log e base 2 into cos x. So cot x by cot x into log e base 2. So this is dy by dx. Now derivative is to be performed with respect to 2 to the power x square. So z equals to 2 to the power x square. Function of function. So what is dz by dx? So 2 to the power x square into log 2 into dx. 2 to the power x square into log 2 into dx. So by chain rule, now by chain rule you have to find dy by dz. Dy by dz is equal to dy by dx into dx by dz. So put the values and you get cot x into log e base 2 into 1 by, because it is reciprocal of dz, 1 by 2 to the power x square log 2 to x. So consider the given function as y, and with respect to this is z, find dy dz. Next, third one, you complete it. Differentiation of sine root x with respect to sine inverse x. Now, number 4. Differentiate x to the power x with respect to x log x. So, same technique, y equals to x to the power x. So, base is variable, power is variable. So, you have to take log on both sides. So, what is log y? Log y equals to x log x. Now, 1 by y dy dx. So, this is by product rule. So, dy by dx equals to y into 1 plus log x. So, x to the power x into 1 plus x. So, this is dy by dx. Now, z equals to x log x with respect to x log x. So, what is dz? So, x into 1 by x plus log x. So, 1 plus log x. Now, your main aim is to find derivative of x to the power x with respect to x log x. That is dy by dz. So, dy by dz, dy by dx into dx by dz. So, x to the power x into 1 plus log x, and derivative of reciprocal of dz dx 1 plus log x. So, you are getting x to the power x. So, theory is very simple. Consider given function as y, and with respect to that function, that is z. So, find dz by dx. Now, we consider some more problems, 5, 6, 7, 8. So, suppose problem number 8. Differentiate x to the power sine inverse x with respect to sine inverse x. So, x to the power sine inverse x, I have already stated. So, you need idea of function of function. So, y equals to x to the power sine inverse x. So, x is variable, sine inverse x is also variable. So, you have to take log on both sides. So, what is log y? So, sine inverse x into log x. Whenever you are taking log, then you have to differentiating by polar. So, differentiating, what we are getting 1 by y dy by dx. So, sine inverse x unchanged into 1 by x plus log x unchanged into over 1 minus x. So, what is dy by dx? Y into, what is y? Y into sine inverse x by x plus log x by over 1 minus x. So x to the power sine inverse x. Then sine inverse x by x log xy root under 1 minus x square. Now you have to perform derivative with respect to sine inverse x. So let z equals to sine inverse x. So what is dz dx? 1 by root under 1 minus x square. So by chain rule, what you have to find dy by dz. So dy by dx into dx by dz. So very simple. You need idea of what are the unit differentiation. Log x by root over this into reciprocal of dz dx. What is the reciprocal of dz by dx? Root over 1 minus x square. So for it y, perform dy dx, z perform dz. Now problem number 5, 6 and 7. So derivative of inverse circular function. We should have idea of how to simplify inverse circular function into simplest form. So problem number 5. Differentiate tan inverse. So y equals to tan inverse 1 minus x by 1 plus x. So if we differentiate y directly, then argument is this 1 by 1 plus x square, then dx of argument. So it will be lengthy. So our aim will be to simplify. Try to recall the formula. Tan inverse x minus tan inverse y equals to tan inverse x minus y by 1. So this is already 1. So x is 1 and y is x. So you can write it as tan inverse 1 minus tan inverse x. So this step will be, otherwise it will be lengthy. So now what is dy by dx? So this is 0 and this is 1 by 1 plus x square. Now what is z? Z equals to tan inverse x. So dz dx 1 by 1 plus x square. Now we have to find dy by dz. Now by chain rule, dy by dx, dx by dz. What is dy by dx? Minus 1 by 1. And derivative of dz dx is this, and you have to take reciprocal. So this is minus 1. So answer is minus 1. Differentiate tan inverse this with respect to tan inverse x. Now problem number 6. Y equals to tan inverse root under 1 plus x square minus 1 by x. So all problems of inverse circular functions are already solved by previous videos. So look, y equals to tan inverse x. Argument is not simple. So our main aim will be to put it in simple form by putting transformation. Now root over is given in 1 plus x square. So you know transformation is x equals to tan theta. X equals to tan theta. So what is theta? Tan inverse x. So our main aim will be to simplify it. So this is tan theta 1 plus tan square theta minus 1. So tan inverse sec theta minus 1 by tan theta. So first aim is to remove root over. So aim is fulfilled. Second aim is to express the argument in terms of tan. So tan inverse So if you write it in terms of sine and cos, it will be 1 minus cos theta by sine theta. Now this is tan inverse 2 sine square theta by 2, 2 sine theta by 2 cos theta by 2. So tan inverse 2 to cancel, tan theta by 2 equals to theta by 2. What is theta? Tan inverse x. So this is simplest form of y. So this is equivalent to half tan inverse x. So this is our main aim, to express the given function in terms of simple one. So what is dy dx? Half, then 1 by 1 plus x square. Now you have to see. So the function is tan inverse x. With respect to, you have to differentiate. So z equals to tan inverse x. So dz by dx equals to 1 by 1 plus x square. Now dy by dz, dy by dx into dx by dz. So half into 1 by 1 plus x square. This is dy dx. And dz dx is reciprocal of it. So this is 1 plus x square. So you are getting answer as half. So these are most important. Next, finally, problem number 7. So differentiate y equals to tan inverse root over so here also argument is complicated. So our aim will be to put it in simplest form. We know if 1 plus x and 1 minus x both are occurring, then transformation is x equals to cos theta. So try to recall. Now here x is replaced by x square. So we have to put x square equals to cos theta. So what is theta? Cos inverse x square. Now try to simplify y. So tan inverse 1 plus cos theta minus 1 minus cos theta 1 plus cos theta plus 1 minus cos theta. So tan inverse formula of trigonometry 2 cos square theta by 2 2 sin square theta by 2 2 cos square theta by 2 with root 2 sin square theta by 2. So if no restriction of theta is given, we suppose it is in first quadrant. So we do not take, cos square theta by 2. This is mod cos theta by 2. But here we take only positive one. If no restriction is given, we suppose it is in first quadrant. So tan inverse cos theta by 2 minus sin theta by 2 cos theta by 2 plus sin theta by 2. No, it is in simplified form. Now our aim will be to express the argument in terms of tan. So what is y? Tan inverse. So divide throughout by cos theta. Is the previous one 1 minus tan theta by 2 1 plus tan theta by 2. Because our main aim is to express it in terms of tan. So this is tan inverse tan pi by 4 minus tan theta by 2 1 plus tan pi by 4 tan theta by 2. So meaning remaining same. So 1 and this is formula of tan inverse tan pi by 4 minus theta by 2. So pi by 4 minus theta by 2. So what is theta by 2? Theta by 2 is cos inverse x square. So this is our main aim, to express y in simplest form. So what is dy by dx? Minus half unchanged, 1 minus root over 1 minus x to the power 4, then minus of derivative of cos is minus, so this will be plus. So x by root under 1 minus derivative of x square is 2x. So main aim is to differentiate it. You have to differentiate it by function of function rule. So now what is z? Z equals to cos inverse x square. So dz dx. So 1 by 1 minus x to the power 4 with a negative sign into 2x. So by chain rule, dy by dz equals to dy by dx into dx by dz. So x into root under 1 minus x to the power 4, then reciprocal of this one is, this is reciprocal 1 minus x to the power 4 by 2x with a negative sign. So we are getting minus half. We are getting minus half. So derivative of tan inverse root over given function with respect to cos inverse x square is minus half. So consider the given function as y, find dy dx, and the function with respect to differentiate as z, find dz dx, use chain rule, find dy by dx. So this is derivative of a function with respect to another function. So today I have discussed differentiation of a function with respect to another function. And I have solved some important problems. Thank you for today.